Well, hello there everyone. So here we are. Um, Yet another stream. So let's get right where we left and let's try to get something into orbit. Alright, JNSQ exploration, and let's load this save. So last time we tried to launch 3 times our new rocket based around the 3 tamper boosters as the first stage. But those launches weren't quite successful because each one of them had suffered one ignition failure from one of the solids, and this wasn't really ideal. But hello there, C7. But this time we will properly static fire the booster before we actually launch it. Alright, so let's open our Marsh A rocket and let's turn it into a static fireball thing. So let's get so the root part is this one. So let's take a probe which we will need to control the thing. Let's make this the new root part. So there we go. Then we can get rid of the first stage. We do this, and now we have a perfect first stage to work with. And finally, let's install a couple of braces. Wait, no, let's make the booster root part. There we go. Now let's install a couple of braces so that it doesn't tip on the launch pad. Alright, now that's a stable rocket. A control part. A cheap control part. Not two, one. And then let's reduce the fuel loading. Like this. And let's build this first stage. Warp to completion of our vessel recovery from previously. To the reconditioning of the launch pad. And then finally to the completion of the rocket. Alright, is there a way to speed this up? I don't know. Global control. Alright, roll out. We are nearly there. Roll out. What was that? There was a blue glow over there, but I don't know what it was. And let's launch it. I don't care if it's night. Alright. Alright. So first we will activate both of these side boosters. Perfect. Now let's avoid staging and let's straight up activate the core. That was a success as well. Alright, that was pretty successful. So now we will recover the vehicle to the vehicle assembly building, of course. So now what we're gonna do is we're gonna build the upper stages, build the satellite and the upper stage, and then we're gonna mate the two vehicles. Alright, let's head over to the VAB. I don't remember what I called the satellite. It was probably some very stupid and unimaginative name. Why do names have to be so hard? It was Oak1. What the hell was I thinking? So, alright. So, let's have a decoupler. Let's not have this covering. Then we had two fuel tanks, a pug engine, and a decoupler. Alright, let's build it. Let's get out of here. So now we're building the upper portion of the rocket as a separate vehicle, and then we're gonna combine it with the proven first stage. And work to completion. Some science transmitted from I don't know where. Wait, 32 science is good actually. That's almost a 45. The next science node is not that far away actually. Okay, there we go. The Orc-1 satellite is ready, so we edit it. And now we will merge it with the Marsh A vessel. Oh, nice, it's already oriented in the correct way. So let's get rid of these stabilizers and refuel the boosters. Grain geometry is correct. These tanks are all filled. Now let's check our staging. We have the first two boosters, then the staging event, the other booster at the same time, then this one, the stage. Alright. Save edits. The rocket did not disappear, that's positive. And the upper stage mating is almost complete. There we go, we can roll out our vehicle. 4 hours. Now we can launch it. Come on, I believe in you. There we are on the pad, so let's turn on the SAS. Let's open the terminal for KOS. Open terminal. And we're gonna copy path 0 PE detect edit PE detect, just to be sure that it's the program we want. Wait until ship orbit periapsis is greater than 85,000. Set total to 0. That's perfect. So now we run PE detect. Amazing. Close terminal. Now we are running the program that will automatically shut down our engine when orbit is reached. So now let's engage precision steering. Launch. It worked. All right. Liftoff was successful. We have a short circuit in the probe, but I don't think that's really a problem. Let's have a bit of gravity turn. Well, the rocket at least is very stable. Those big fins are doing their job in keeping it pointing flamey ends down. Also, why do rockets always roll like that? And staging. Yes, that was a clean staging. And our apopsis is already so high, we better do some gravity turning. This launch is going well. Also, we are quite high up already. Those SRBs sure are fast. So let's just point horizontally. That is kinda negative due to drag, but who cares? We need horizontal velocity. And shut down. Boy, it worked. Nice. Alright, now we'll get to space. Now we are into space, so we can separate the booster. We can ignite the PUG engine, and that was successful as well. So now we need to burn for probably a couple of minutes. Yes. So we'll actually start our burn a little bit before we reach apopsis, which is at 216 kilometers. Also, I locked the staging because you never know. And now, also deploying communication antennas. Automation. And let's set everything experiment to waiting. And let's start warping to apopsis. Alright, I'll point slightly above horizontal. Also, let's roll to a correct attitude. Okay. I point slightly towards above the horizontal. Alright. And starting the engine. Now, I might lose sight of the KSC as I'm doing this burn, but the engine will shut down itself, hopefully. I have tested it and it should work. But this mission is already going very well. Yeah, it's kind of slow. But so are real life rockets. We need to get to like 3.9 kilometers per second of speed. And that will take some time. That's also the reason why I'm slightly pointing up. Well, let's point up a bit more. 20 degrees. I have plenty of propellant, so I can afford it. And look at how far the KSC is. Alright. It's said that I forgot to turn on my experiments on the launch pad, like I was supposed to do, so that they could get some science from high atmosphere, but that, well, that was a secondary mission. Oh, also we broke the 3 kilometers per second barrier. And look at the much wider orbit. Also, I think we can pitch down a bit, like to 10 degrees, because now the centrifugal force is starting to relieve us of some weight. Also, let's straight up pitch down to 5 degrees, more or less. Also, even horizontal. Burn is almost completed. Let's see if it shuts down itself. Yes, it worked. Perfect. It worked perfectly. Just as I intended. That's lovely. And I think the program ended. Let's see if the terminal tells me. Yes, program ended. Lovely, lovely. Let's straight up screenshot the UI because I'm really proud of myself. This is the first KOS program that I write, and that actually did something useful, very useful. Well, its services were not really needed this time, but it was nice to have it anyways. And we lost contact. So had the burn been just a little longer, like it would have been on heavier payloads, that would have really saved our lives. Now, what we want to do is we want to wait until we are at descending or ascending node, and then transfer to this orbit because that's the contract we want to complete. Yeah, we did a bunch of stuff. Vessel and eco capacity non-orbit, right? So now let's wait until we are there, and hopefully there will be a ground station. Also, is the electric charge? The electric charge is being kind of depleted. Oh, come on. And the solar panels are only on one side, which means that we have to expose them before it's too late. Alright, we are recharging. And also let's hibernate. Let's set the probe to hibernation in warp if that's a thing that applies on Kerbalism or anything. Well, no, it's not an option anymore. Well, whatever. Well, we are at a node, I guess. Well, I'll wait until next node so that I don't, so that I do not have to hide the solar panels to do the maneuver. Yeah, batteries are almost empty. Yes, we lost electric charge. Relax, battery is recharged. Perfect. Wait, which one is me? Yes, that's that. Okay, so we can point prograde and work there. We have absolutely, our delta V is absolutely overkill for the mission. I estimated that you need around 1600 meters per second. We have much more. And I'm doing everything, we completely eyeballing it. Oh shoot. Alright, that's kind of slow. We are getting there. We want to keep the number of ignitions low because those are a limited resource in Kerbalism. So let's reduce thrust and shut down. Very precise. I love it. And maybe we'll also get some science from high space, hopefully. So more science. Also, look at those nights. Oh, yes, the funds are not here yet because I have yet to complete the contract, of course. Now let's see if I get any trigger for... Yes, we are in high space. Probably starts at around 900 kilometers. That's reasonable. And we are getting science. Maybe we'll also get data from a different radiation belt. Yeah, we might. Oh no, wait. Maybe not. Focus here. Panels are always exposed. Alright, let's start pointing our space. Right, signal acquired. Let's start pointing our spacecraft. It will be prograde. Slightly radial in and slightly normal. So like, no. I still can't read the nutball as far as normal and normal goes. But kinda like that. We might need some corrections in the future, but more and more normal. Right, plane change is complete. And now, oh, that was even too much. Okay, now we can just focus on the shape of the orbit. Alright, contract completed. 26,000 funds. For an actual satellite. Also, where is this light? Oh, it's on the KS probe. And let's point our satellites towards the sun. Let's not decouple the stage because we are not stupid. Also, I think, yeah, stage lock is engaged, so no accidental decoupling. I think the amount of people who do not know about stage lock is like astounding, but it's such a useful feature to be able not to accidentally hit the spacebar and completely ruin your mission. And radiation scan, magnetosphere, space high, space high. Where is our science? So it is 6.3. Back to our space center. Well, we finally did it. We got a heavy satellite into orbit. That launch vehicle has a payload capacity of 1 ton to allow Kerbal in orbit, so that's quite useful. It might even be able to get a small space probe to the moon. But let's see what contracts do we have. Now, I think we still have established stable orbit, which will pay us a lot of money if we establish stable orbit with an uncrewed vessel and then return to Kerbin, which we now possess the technology to do. So that's something we are going to accept. Yes. Now, anything else? We have satellites in orbit of Kerbin. This one is very far out. Same for this one. This is slightly nearer. Might even be doable. Maybe in the future. Now we have started exploring moon, ComSats, and part testing. Is there like maybe something to test a single part in orbit or something at the launch site? 86. Escape trajectory. Oh, heat shield, stage decoupler, radial decoupler. Well, none of these are really interesting, so I think I might get one for the launch site. This doesn't pay good. This is a orbital trajectory. Well, this is the best one. So now, first, we will design a spacecraft that we go to orbit and re-enter. It will be designed, of course, on the octopod line. Then we're gonna want a KOS core. Nice. Then, do we have the payload bay? No, we don't. What we do have, of course, is the heat shield. We have a parachute that's gonna be needed. We have a heat shield for 1.25, so that's pretty much a choice, a very easy choice. Now I wanted to know if there was something to encapsulate this stuff. Communication, science, electricity, aerodynamics, not really. If this one, but that's not so good. I usually use a 1.25 meter payload container for these sort of things, but apparently here it's not an option. So what experiments do we want? Well, basically the mystery goo, because that's only doable in orbit, because that requires you to return a sample. So since we will be returning from orbit, that's what we will do. Now, have we done it in high atmosphere? landed, flying high. So there's actually a reason to just put one to flying high. So I'll just keep it there. Now Mr. Goo is kind of our hungry, I think. Last 10 minutes, and because, well, not that much. Actually, one Mr. Goo just requires more or less 100 units of electric charge. So that's not too much, but 2 batteries will suffice. Provided that we also have solar panels. So let's put the batteries there, the solar panels here. Then what else do we want? It's low orbit, so I don't think there's any more science we can collect. Maybe we should do the might experiment. Oh no, that requires a polar orbit. The light has already been done. So I guess we can just leave nothing there. Or maybe we still need the Geiger counter in space high, no. Oh, in fly high, no. Bathymetry, telemetry. Alright, let's leave it without any experiment. Perfect. Alright, what else do we want? Now we have the heat shield. Now let's see. Engineering report. Parachuting first stage. Electric charge. Alright. Well, let's get a couple more antennas maybe. With these. Then what else do we have to worry about? Stress habitat, that's not a problem. Perfect. Now what's our mass? 600 kilograms. So that means that the upper stage will have plenty of fuel left, and so it will take care of the deorbit burn. Now let's test it. Mostly we want to test if it is aerodynamically stable. So, oh wait, I can straight up simulate our re-entry. So let's have just 100. Okay, simulate start in orbit. Right, we'll simulate just the re-entry. Because that's the part that actually matters. And to do so, we will start our journey in orbit. Oh, okay. It always starts like on the launch pad, and that's weird. Yeah, it's also okay. Signal acquired. Let's fire the retro rocket. Okay, that's deorbited. Activate the parachute. Disengage SAS. Okay, let's leave it in this attitude and let's see what happens. I don't like this. Let's give it a kick. Alright, let's hope it is stable. Okay, let's also leave SAS on. I don't like that overheating bar. We lost control. The probe is on its own. That's a lot of velocity to shed. Now maybe that was due to leaving the SAS on, which made the probe rotate, so I'm restarting the simulation. To see if maybe leaving the SAS off helps. Activate the parachute. Atmosphere. Transition to surface. SAS off. It's definitely not stable. Now let's maybe leave it in this attitude. Oh god, this is so stressful. Nice, now I lost control. Let's straight up the heat shield that's overheating. Now we are without a heat shield and everything is going kaboom. Now, terminate simulation. Now, what the hell of an heat shield is that? Is it even programmed to resist decent temperatures? Oh god, 2300 degrees. That's not very good. So, that's a problem. Because pretty much we don't have a... Now that's a problem, we will solve this string. So, let's go for a less steep oriented profile, but, well, no, actually. Let's go for a steeper oriented profile. Yeah, that's the answer. A much steeper oriented profile. Basically, we will shed away so much velocity that during the orbit burn, that the heat shield won't have to disperse that much heat away. So we'll basically be going for the opposite of our strategy. So this time the motor has been loaded with a full propellant loading that will slow us down quite a bit. Like on the pond rocket, this was straight up used for orbital insertion, so that will basically put us on what is more of a suborbital trajectory, literally. And let's see if this works. Like, look at that, we are already much slower. Well, not quite enough, maybe? Or why do you have to shake so much? I can't see. Oh, okay. Looks decent. Oh, no, 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 no. Oh, no, 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 no. Did the spacecraft lose power? No. Could have gone better. Now, we have the problem that this spacecraft isn't aerodynamically stable. So we have to solve that. Hmm. Now, what can make these spacecraft stable? Basically, we would have to move the what with the center of mass much down. Where is it? It's here. I don't. Well, let's just move in the mystery goes to the floor. But I don't think that's gonna help a lot. So instead, what I'm gonna do. What's the thermal tolerance of the parachute? Well, actually, the skin is quite durable, so I'm gonna take another heat. I was thinking about something that goes nose first. How heavy is the parachute? Well, kinda. Maybe if we do this. This is kinda stupid. No, let's not. But hey, it's actually might work. Let's see. Again, with the same strategy of the orbit shedding away a lot of velocity during the orbit burn. Okay, let's spawn. Of course, the SRB is pointing in the wrong direction. So is the decoupler. No, the decoupler is fine. Yeah. Oh, the select. Start simulation. Things like it. I'm so tired. Alright, let's have this other attempt. Also, these simulations aren't really free. That's to be noted. Okay, we are slowing down substantially. Separation, parachute activation, and let's turn to face our fiery re-entry. Now this is either a stupid idea or a genius idea. I really have no clue. Now if the heat shield goes into overheating before the parachute, this is a genius idea. Actually, it looks like that's the case. The probe looks stable. Now there's the thing, well, if we lose the heat shield, we're gonna lose the parachute as well. So it's all or nothing. But it looks like everything is holding up. Looks to be aerodynamically stable in this configuration. Yes, it's decelerating. Come on. Heat loading is decreasing, and yeah, we did it. And it looks like the probe really is aerodynamically stable. Terminate simulation. We found a satisfying design, so we can launch it. So this is the probe. So let's call it Diver 1, because it will dive into the atmosphere. Now, all that's left to do is pretty much to build an upper stage, and then we are going to do the same static testing of the first stage of the Mars rocket. Now you have to find a place to stack a TD12 decoupler, since we used the attachment node that was supposed to hold the decoupler, which is unfortunate, I guess. Is this gonna kill me if I do this? Oh wait, I have this, then I will rotate it, then offset it, and the game shouldn't be mad at me, I hope. So now let's get 2 tanks and a pug engine. Finally, we are gonna have a TD12 decoupler. So now that's the upper stage of our rocket. We won't save the changes because these are temporary, so let's just add it to the build list. Then we're gonna open the Mars rocket, and we're gonna do our usual thing where we build one that's ready for static firing rather than flying. So we reverse it, then we get a couple of structural supports there, a dirt cheap space probe, and finally, okay, so now let's call it Mash A static. Reduce propellant loading, and let's save it, or also save it, yeah. And lastly, we need a TD06 decoupler to complete the contract. Come on. Why doesn't it let me? Oh, anyways, we already added the thing to the build list, so we have to modify it from there. Alright. Building plans, BAB. Edit mesh a static. One day, missions will take so long that I'll be able to build rockets while I fly others. So TD06, let's add it here, here, and save it. Now hopefully, yeah, it took some money to do it. And let's keep everything this way. Warping time. Another science transmission, I don't know what it was. Stage destroyed, so that was not my science report. Okay, now next in line is diver 1. And diver 1 is almost complete. Our upper stage is now finished and in storage, so we now wait for our first stage. Our first stage is completed. So roll out for the statics test. Oh, now I get why the rollout time difference is so great between the static test article and the actual rocket. It's because the test article is almost completely unfueled, so it's much lighter. And that's what makes it so quick. Now let's have first our test. Now we tested the coupler, that's some money. And let's test the two engines, well, motors. They fired without a problem. Now let's do the same for the core. No problem either. We are generation 10 and SRB safety rating 9. That's respectable. Also, I was starting to wonder how realistic it is for an SRB not to fail to ignite. Like, how can it possibly do it? I mean, it can be ignition can be aborted during by mission control because maybe they think there's a problem in some system of the SRB or something, but I don't think it's really likely for an SRB to physically fail to ignite. Like, what can possibly go wrong? Anyways, we can now proceed to integrate the, well, first to recover test article. And okay, now we modify the diver spacecraft. To give it its first stage. Merge with a built vessel, specifically mash a static. Let's get rid of all this stuff and let's check our staging. So first stage, second stage, third stage, payload, then fill boosters with solid propellant. Propellant grain is fine. Rocket is fueled. Save edits. They will take 2 hours, and then it will be another more or less 4 hours for rollout. So it should happen at Kerbal evening, I guess. Perfect. Rollout. Now again, this mission will launch a spacecraft that will go into Kerbal orbit, perform the mystery glue experiment, and then obviously come back, because in Kerbalism, Mr. Gu has to be recovered because it's a physical sample being analyzed, so that means it has to be retrieved to a laboratory in order to actually give it science value. Also, I guess this will be this KOS probe. I think it will have a terminal. No, I think this is a terminal ID numbers too, but I don't know. So yeah, this is a realistic KSP mod. This is the Kerbalism realism system that affects science and life support. So now copy path, because we want to import our stage shutdown program on this KOS probe from the main computer. So PE detect. Maybe there's a way to do it automatically, but I don't know. Run PE detect. It's not throwing an error, so that should be doing fine. I say yes. Precision. Precision. Now let's start a mystery glue. It's set to waiting, so it will activate in an atmosphere and launch. And let's start a gravity turn, because I waited too much for the other launches and it was ascending too fast. No, this is a too aggressive gravity turn. Now that's fine. Almost lost control there, but now everything is going fine again. And these solids sure are fast. Staging. Our apoapsis is already quite high, 63 kilometers. 75. 80, that's space, basically. So now we can burn horizontally. Oh, we are too low. And drag is killing us. giving us a lot of speed, but that's also good because that's observation time for the mystery glue and burnout. Well, mystery glue is running, so that's nice. Of course, our apoapsis is quite high nonetheless, so now we're in space. Let's extend the antennas. Also, the mystery glue is it's really a low value. It's almost not even worth it. Well, actually coupled with the contract reward, that should actually be an interesting science return. Now we can stage, activate the engine, lock staging, prevent doing anything stupid. And soon, alright, let's start orbital insertion burn. The automatic shut-off program should be running in the background. Now let's pitch to 10 degrees above the horizontal. Now circulation should take around 1,500 meters per second, leaving us plenty for our important deorbit burn that will be necessary to relieve the spacecraft from the thermal loads of fast re-entry. But as you can see, the insertion burn is quite slow. Let's pitch up a little bit more. Trying to find a good lighting. And there's no point in trying to get the spacecraft into high space to observe Mr. Good there, because given that we already have a sample from the high atmosphere on board, there wouldn't be enough storage space for three different samples from different situations. So we're pretty much stuck. Well, it's not stuck. That's just that's just the objective we had. So now we can pitch down because centrifugal force is starting to relieve the probe of some weight, so we no longer need to compensate with the engine, and we can go on an efficient trajectory. The KSC is on the horizon, so we might lose connection soon. Orbit is being achieved. Orbit achieved. And even this time, the aid of the program, of the shutdown program, was not necessary. Well, by a very slight margin. It's a shame we didn't get to expose the solar panels, but this time we have plenty of electric charge. That's not really a problem. Now we will recharge our batteries as soon as we get to the light side, and then we'll perform the Mr. Go experiment. We have established the radio connection. Power is back online, so we can perform the Okay, so now let's stop this Mr. Goo and let's start this other one. Now that will be 10 minutes. Electric charge is actually increasing. Let's take a screenshot of this hard-going spacecraft. Connection timed out, but that's not a problem. The science is still running. And it's completed. So now let's stop it. Oh, the KOS probe has a flashing light. Does this? Nice. Alright. Well, we have nothing to do but go home. That's really the tricky part. So I think we might, well, we'll do it on this ground station on the next pass. Because we'll start our, well, no, actually, well, yeah, we'll do that on that ground station. The orbiting will take 2 minutes because we're gonna burn all of our fuel in order to lose as much velocity as possible. Because our heat shield is really weak, like a lot. Like it's really a beta heat shield. We picked up the ground station, so now let's swap a bit ahead in time. Okay, so now let's point retrograde. Our electric charge is full. The orbit burn. Why doesn't it? Why doesn't the thrust go up? The accelerator is really... Oh, maybe it's because of the program. Open terminal, but the program ended. This is weird. So I look for another opportunity where I'll try to, next orbit, where I'll try to turn on the engine by using KOS, a KOS command. Do we have electric charge? Yes, we do. The probe is good, right? Yeah, it's not highlighted in any failure. Okay, now open terminal. Set throttle to 1. Excellent. So we turned on the engine via a KOS command instead of the usual keyboard inputs, because somehow those didn't work. Okay, 3.5 kilometers per second. I hope we get to below 2. Well, below 3. Like in the simulation, it worked at like 2.8 kilometers per second. And it looks like we're gonna make it. I'll retract the antennas at the last possible moment because I don't want to lose communications. Three kilometers per second. Still 1 more kilometer per second in the tank. 2.8, which was basically what this was designed for, well, what this was tested for. I can't really say this was designed for any specific speed. This was like quite rushed. We're almost in the atmosphere. Alright, well, no, let's not retract all the antennas. Two kilometers per second. We hit the atmosphere at 2.2. I shut down the engine. And let's activate the parachute. Let's retract the antenna. And let's deactivate SAS. Alright, this is the hardest part, but we are already below 2 kilometers per second, so that's probably very survivable. The parachute is set for deployment. We are still not losing speed. Come on, start decelerating. I know you want to. It's decelerating. Thermal gauge appeared, but I don't think it's for the parachute. It's probably for the heat shield. Yes, it is. The upper stage exploded. 1600 meters per second, 1500, and pretty much we're done. We survived. It would be nice if we also got signal recognition. Yes, we did. So let's let go of SAS. And let's wait for parachute deployment. There we go. We also lost control because we lost radio contact. And we can warp until we hit the ground. 10 kilometers from now. Parachute is fully deployed. Descent speed is quite low. Well, 5 meters per second is actually substantial, but manageable. Alright, 100 meters, 80, 70, 60, slow down time, touchdown. What a nice end for the mission. We recover normal recovery. Also, this should count as a milestone as well, because this is probably the first time we recover something that came back from orbit. So it's one more milestone, which should also give us extra money. Indeed, 89,000 funds and 49 science, because we got the 2 mystery goose, the recovery of a vessel, a return from orbit of Kerbal, then all of the parts, all the funds from the parts, milestone, contract. Now let's see what contracts gets offered to us. We have investigated manufacturing satellite. We have the normal satellite contracts. Exploration plus offers start exploring moon. Kerbal and achievement offers first Kerbal in space. Explore the moon and explore Memos. Well, that's something I'll figure out probably next time. But first, before leaving, let's see which science nodes have opened to us. We have 45 science points to spend, so we might go for advanced rockets. So bigger fuel tanks, the Terrier engine, which is a nice upgrade in thrust from the PUG. Some liquid hydrogen engines and methane engines. It's weird to unlock them this early, but actually, due to the part limit, hydrogen with its low density requires many tanks, so it's actually kind of balanced. Also, we would have the site experiment, which I think is relative to multiple biomes in ice space, so there's a lot of science to grind there. Then construction gives us a magnetometer, so more science. Adapters, weird gun structures that I don't think I'll ever use. Fairing, fuselage, flag, oh, the launch thrust and the service bay. Nice. And engine plate. Then we have aviation, which gives us plane parts, which we don't care about because I'm not a plane guy. Sorry, plane guys. But we have a light, which I kind of fell in love with watching my cabin stream because its props are so full of blinky lights and they look so cool, and I want to emulate that. Here we have reaction wheels and most importantly RCS. We just have the inline tank, and no radial one. That's not so good. Maybe it's here. No. Here we have parachutes and the decent heat shield. This is actually really tempting, but well, we are not really going for crewed spaceflight quite yet. I think I'll be focusing more on moon maybe, especially because of the potential for science and because I don't really trust the reliability of my systems yet. And here we are basically probes, antennas, some science. Oh, we have this experiment storage unit, the other experiment return unit, and several upgrades. You earn science, or so Vietnamese toast. In Kerbalism, you earn science basically the same way. What changes is that experiments take time to complete, so it's not an instant thing. You have to leave the stuff there for sometimes. For example, the mystery glue takes 10 minutes of exposition, which also means that if you want to collect science from a certain place, you have to stay in that place for that time, and for places like high altitude or maybe some biomes, that's tricky. That requires some piloting skills. And also, they do not generate science points that majorly get back to the KSC. They either generate data, which is basically physical data measured in kilobytes, which you have to store on probes and to transmit back to the KSC for it to actually count. And both of those problems are challenges because storage space is limited on probes, and so is transmitting capacity of your antennas. So you have to factor these things into mission design. And then some experiments straight up need to be returned because they are physical observations of a sample, like the mystery glue. So it's a more realistic way to do science, and the science point system otherwise is unchanged. And I really can't decide on which thing to unlock because, like, you don't feel like you really need a single node. You kind of want to unlock them all at the same time because you just want to build a next generation spacecraft. You don't just want to add a single file. You really want to step up the game altogether. So, well, no, I'm just playing KSP for the sake of KSP, whatever, whenever this is unrelated to when KSP2 is going to come out. I think I might actually go for this one, but I'm not sure. Let's think. Oh, this one has also the high gain antenna, which enables me to build relays. This is actually tempting, but actually it's not that crucial now that I have the uh, periapsis detect program. So that's actually not as crucial as it was in previous games. And otherwise, what do we get here? Basically, the radar altimeter from Scansat, which is nice, basically for contracts, but not essential. Now, what we want to do now is explore the moon. So in that optic, I think having the magnet, either it's between advanced rocketry and general construction, because one gives you the magnetometer and the other gives you sight. I'll go for advanced rocketry. Now that decision was taken, and with that, I think we can end the stream. I am very satisfied of what we accomplished this time. We launched 2 rockets, both times successfully. Uh, we didn't really encounter problems with the static fires, but it was nice to launch them with the confidence that the booster was tested. We achieved 2 important contracts. We returned our first spacecraft and science uh, to the ground from Kerbal orbit. So that was quite eventful. I hope you enjoyed following me in my exploration, and I see you next time. May your launch streamings be in during daylight, and also may everything go well for JWST, since that's what we all have in mind these days. Until then, bye.